Hello friends, welcome to my channel. Let's have a look at problem 872, leaf similar trees. In this video, we are going to share a solution based on traversal plus filtering. So here we are going to provide two formats. So one is in the iterative format and the other is in the recursive format. First, I'm going to read through the problem statement to digest the requirement. And then we do the analysis, and finally we share the codes. First, the statement. Consider all the leaves of a binary tree from left to right order. The values of those leaves form a leaf value sequence. For example, here the leaf value sequence is 6, 7, 4, 9, 8, right? This is from left to right. So the two binary trees are considered leaf similar if their leaf value sequence is the same. So return true if and only if the two given trees with head nodes root 1 and root 2 are leaf similar, otherwise return false. So that's the problem statement. So let's look at the two examples. So in the first example, the two trees are structurally different, as you can spot. If we examine the leaf value sequence for the first tree, it's 6, 7, 9, 4, 9, 8, and the same for the second tree. So we should return true for this example. So well, for example 1, so if we look at the leaf sequences corresponding to the two trees, the first one is 2, 3, and the second one is 3, 2. For sure, and these two sequences are different, so we return false. Before we do the analysis, let's also have a look at the constraints. So first, the number of nodes in each tree will be in the range 1 and 200. So 200 is not a very large number. So this actually gives us an upper bound for the problem size. Secondly, this constraint is on the values of the nodes. So they are in the range given by 0 and 200. So this is a closed interval. So in particular, we know the node values are non-negative, but this one I feel is not very essential for our solution. So with that said, we are ready to do the analysis. So here for this problem, we just need to get the leaf value sequences. So we can do traversal. Any traversal will do as long as we can maintain the left and right order of these leaf values. So here actually we can think of in-order traversal. So in-order traversal for a binary tree is that we first do in-order traversal for the left subtree and then traverse the root itself, then in-order traversal for the right subtree in a recursive format. So if we look at this example in the main problem statement, so the in-order traversal list is going to be 6, 5, 7, 2, 4, 3, 9, 1, 8. So if we filter out those values that are not corresponding to leaves, so we're going to have 6, 7, 4, 9, 8, right? Maintain this order, 6, 7, 4, 9, 8. So as demonstrated here, so in the coding part, actually we can do in-order traversal, and in between we just store the value of a leaf node. That's just an extra check in the standard in-order traversal. So with that said, we are ready to do the coding. So here I'm going to do two formats of solutions. For the first format, I'm going to use iterative format. So for this, first I'm going to define an in-order hyperfunction. So this is a standard in-order traversal function for a binary tree. So it's actually very routine to write. So let me write quickly and explain with some detail. So I'm going to call this function in order to demonstrate this, to emphasize this is a hyperfunction and the order for visiting node. So I'm going to initialize a result, and then the stack we're going to be empty and the current to be root. The result is going to store the traversal result. The stack is going to maintain or help us to gain in-order traversal. The current is the current state of the root. And then we're going to do the standard in-order traversal while loop, while current or stack, right? Then first, if current is not null, so we want to go to the very left, right? So go to leftmost. So this can be done using a for loop, a while loop, right? While current, then we're going to append this current for feature pop, and then we're going to do current equals current left. So this way, once we exit this while loop, the current will point to null. So for example, here we're going to go to 3, 5, 6, then the current will be null. Then we're going to update the current. So then we go to right. So once we, for example, we up to here, then we want to go to 2. So what we're going to do is that, so we're going to do go right and up. So this is actually easy to get. So current equals stack pop, right? And then what we're going to do is to so in this case, so we're going to result append current value, and then we're going to set current equals current next. So this way, if we return the result, it corresponds to the in-order traversal of the whole tree. So let's do a check. For example, this one. Right? In example 1, let's print this out. In-order traversal root 1. Let's print this out. Tree node has no attributes next, so sorry. So here should be right. It's not linked list. So right. So if we do this, so we are going to have 6, 5, 7, 2, 4, 3, 9, 1, 8. This is standard in-order traversal. But this does not take into consideration of the problem logic. So here, this is what we store, right? So, but if we add a condition, just a filter, so add a filter for the current problem logic, then we're going to get the leaf nodes. So this is actually easy done. So if not current left and not current right. So this tells that, so this is a leaf, right? So if it's a leaf, so we're going to store its value. And then we do the standard in-order traversal. Let's check it again. So if we run the code, so here. So we are going to get 6, 7, 4, 9, 8, right, as expected. So once we have this hyperfunction, and then doing the coding for the remaining problem logic is actually straightforward. So let's do it now. So first we are going to call it array1, array2, right? So it's an in-order traversal of the 2 roots. So in-order root 1 and in-order root 2. What we want to do is to check if the 2 arrays are the same, right? So you can do a for loop to check the elements, or you can just do this. This is a shorthanded equality check. So with that said, we are ready to do some test. Let's test for example 1. So this returns true. So now let's look at example 2. So this should return false. So yeah, this should return false. And then let's do a check for the generic case. Yeah, it passes all the cases. So this provides us a solution format for the in-order traversal with iterative format. But here the main point is the in-order traversal function. So if we know the in-order traversal function, then the only line we added is here to take into consideration of the problem logic. Then all the other parts are straightforward. So this is the one solution. So next, I'm going to copy this function signature and then I'm going to write another solution format. I'm going to call this one solution v1. And then for this, I'm going to use recursion. So this recursion actually is still the in-order traversal. First, again, I'm going to write a hyperfunction. So for this, I'm going to call this function again, define in order. So this accept a root, and then we're going to get leaves. So this leaves will be an empty list at the very beginning, right? So if root is null, so in this case, we just need to return leaves. So then what we're going to do is that, so we're going to so do this. So we're going to call this in order. So root left, then leaves, and then we're going to check if not root left and not root right. So in this case, it means the root is a leaf. Then we're going to do leaves append root value. So once we've done this, then we're going to do this in order for root right, and then using the current state of leaves. So this is our hyperfunction. You can understand it as a worker, right, to modify this guy. So with that said, so we are ready to do the problem logic. So for this, first I'm going to initialize result 1 and result 2, or array1, array2, which is much better. So array1, array2. So it's going to be an empty list. And then what we're going to do is I'm going to call this in order function. In order, so root 1, array 1, and in order root 2, array 2, right? So this way we obtain two arrays, array 1 and array 2. So actually we can print them out, array 1, array 2. Let's do a check. Yeah, for the second example, so for the first tree we're going to have 2, 3, and for the second tree we're going to have 3, 2, right? So now what we're going to do is nothing but compare, right? Return if array 1 equals array 2 or not. So let's do a check. So this is false, as expected. Now let's look at the generic case. Yeah, it passes all the generic cases. So this is another format of solutions actually parallel to version 1. So notice that in this current format of writing the code, we modify the leaves. So leaves is a mutable thing. So that's actually an important point to observe. So if you compare the two solution formats, they are essentially the same solution. In other words, in-order traversal plus filtering, but one in the iterative format. So personally, I prefer the iterative format. The reason is that we know more details, like here. So that's what's the logic of the problem. So similarly, here in this is also the same logical check for the root values. So only it's a leaf, then we modify the leaves array. So, but the second one is shorter in length, but they are essentially the same code. So overall, I guess the key point for this problem is the ability to write the in-order traversal function without difficulty. So with that said, I guess that's about it for this video. So we have a number of problems, or actually a large number of problems related to the binary trees and the traversals. You are welcome to check out those. With that said, I guess that's it. Thank you.